with that to continue the biometrics. And these are things that, I mean, the laptops he's going to buy may wind up having biometrics on it. When you do these things, and I don't have one that does have biometrics, I'm a cheapskate. What happens if you like burn your finger and it changes the shape of the fingerprint? And usually you're going to do 2 or 3, not just one, a single one of these things. You're going to have a couple of these so that it has a comparison to do it with. Retinal patterns, voice patterns, fingerprints, all of these things, facial recognition, things that we can use biometrics, something we are, something we know, something we have, something we are, something we do, again, is kind of an add-on to these things. And what we use here, digital certificates, and you have seen these, and let's go ahead and see if I can bring one up. And let's do learning.leaderquest online, see if we can see their certificate. When we go through here, maybe, or maybe it's not going to let me go there anymore. Maybe I have used all of my bandwidth. So we have here, says the certificate is valid. Yeah. I've gone to a different location. Certificate is valid. Issued to, and this is Cloudflare. This is that ESAA site. Goes to Cloudflare. Cloudflare is where we're going to, and we're using that now. And then we have the details of it. The issuer statement here. When I go to the issuer statement, the legal repository, and all of this stuff is getting a little bit slow because I'm trying to do too many things at a time. And it's getting mad at me. So anyhow, we'll look at this thing, and the digital legal just tells me all the stuff that's going on. And it tells me I have to accept the cookies, and it won't let me accept the cookies, and around and around and around the world. So I managed to lock myself up here, probably because I have this open. But we have this available. We have the details that go on the version. These are the standard certificates for these things. The serial number, signature algorithm, it's a SHA-256. The signature hash uses SHA-256. The issuer of this thing, the validity from October of 2019 to October of 2020, they typically about a year for these things. The subject, what it is, and the subject here, this says that it's Cloudflare Incorporated, typically going to be the site that we're going to. The public key, you can see the public key in here. It's a 256-bit. Not really that strong of a public key. We'll look at another one here if I can get out of this stuff in a minute. The public key parameters, the authority, the subject key, the subject alternative names. And here is something, it is used for www.esaa.com. So it's used for that, and it's also used for cloudflare.com. The reason I say we'll do a couple of other ones when we do those, and that's what it was. It didn't like it that I had those open. Let me go to hopefully to a different location and look at it. One that has a lot of different names. If I can get my fingers on the keys correctly. You can issue these certificates for more than one location, as you saw from that one. This is for my old employer, and we go down here to subject alternative names. This certificate's good for a whole ton of places. The other one is a wildcard. It's just a star in front of the domain. They have a lot of different sites, different names that they use So they use the subject alternative names. What is it good for in the DNS world? What's it good for looking up when we do the comparison to do these things? And then the certification path. Who issued these certificates when we go from one to the other? And then just the general up here, the issuer statement, the certificate information, what's it good for, and here is it valid or not valid when we do those things. So we have the digital certificate is an electronic document used to identify a person or device. You can issue your own certificates. We're going to talk about certificate authorities here in just a second, and I'll show you one that's not working on that Windows Active Directory. Not working because it's old and the new processes that we're using, the browsers aren't allowed to use the protocols that are required for that particular site right now. So we do these things signed by a certificate authority or our self-sign. Now we're getting into certificate authorities. Who can do these things? If we look at, and you can look at your certificate manager, manage computer certificates on your Windows machine. Let me see, as I know I'm slowing this thing down a lot. So I have the certificates that are available here for the local computer. I could go get the ones that are issued for me. We have these trusted root certification authorities in the certificates. These are all of the companies that are trusted to give us certificates, that are trusted to do all this HTTPS business. And all the HTTPS business does a couple things. One, it identifies the site as where we thought we were that we went to where we thought we were. It verifies that if I go to ESA.com that certificate was issued to ESA.com. It has that certificate. The users or the entities that are authorized to issue those are the trusted root certification authorities. The numbers keep growing of these things, and I guess because we used to just have a few sites that were HTTPS, and now everything is HTTPS because of all of the spoofing that goes on and the bogus sites that are available. So that we want to be able to assure ourselves that we're at where we think we are. And some browsers won't even go anywhere anymore unless it is an HTTPS. Let's see. So we can't do certificates. One of the things that I tried to do, and I don't know if it did or not, is to have untrusted certificates here. So these are ones on the disallow list. We have trusted certificates, trusted publishers, intermediate certification authorities. The trusted certification certificates, and I guess when we talk about self-sign, we should look at those things. This is a self-signed certificate. So the certification authorities, those that get the permission to go in here, sign their own certificates. Once that happens, if we go into let's go to an intermediate certification authority, Komodo here, and see what they got. One of the top level, and this one is Sectigo, formerly Komodo. Komodo used to be a certificate authority, and now they become Sectigo. Signed the Komodo certificate. So the certificates have to be signed by somebody. We need a chain of trust to go up the line to them, and I don't know that I have any certificates in here, but if we would go to an HTTPS site, it'll tell us who signed it and what the chain of trust is. And we kind of looked at one of those. Let's see if we can get to LeaderQuest yet. LeaderQuest online. Yeah. So when we look at its certificate, it says it's valid. That's always a good thing to do. The details here was issued 2/9/2020. They had an issue in February that the certificate expired. And when the certificates expire, they're done. They come up with an error. The reason that you get certificate errors is because there is something wrong with it. But DigiCert and then DigiCert SAW2 to myabsorb, and MSAN myabsorb.com is the actual site of this thing. Well, I know what we type in is learning.leaderquestonline.com, but Absorb is the company that does these things. So we have our digital certificates that we use. The certificate authority signed certificates provide more security. Self-signed certificates are free and easy to create. We can create our own. We can generate our own. You can create inside of if you have a Windows server, and there are a number of other places that we can actually do this. Let's see, I think it's oh good. So I want to get my Control-Alt-Delete. This one has a certificate authority running on it. I'll get rid of all this stuff that I messed up. So if we go into here, I have a certificate authority. It's going to be something that's pretty undramatic to see here. What I would do, and this one, I have revoked certificates. I can revoke them. I have some issued certificates, and I know I have actually issued from this last December, but I don't remember how I managed to get there, and I'll show you here in just a second. Any pending requests, I don't have any, and then failed requests that would go on to this thing. It's going to be a self-signed certificate because this is not a trusted certification authority. I can install that certificate and make it trusted. I can install it in my certificate store if I want to, in order to be able to use those certificates. The government kind of tends to do that. So if I were requesting a certificate from that location, and I'll tell you right now, it's not going to work. For one thing, it's not secure. Let's see, and it's 192.168.1.152. Here's where I tried earlier. Search, sir. We would go in here, request a certificate. We could request an email protection or a web browser. We put in all of our information, but it's not showing me everything down here that I should have. I could go in here and install all of this information, submit it, and it's going to be a failure because I can't actually get there. The other thing, advanced, if we create the base 64 encoded information, we can copy and paste it into here and submit it that way. But it has to be generated. The request has to be generated in a proper code in order to be able to do those things. So certificates we use, self-signed certificates, certificate authority certificates. The CA certificates are the ones that our systems just automatically accept when things happen. Self-signed certificates we can do, they're free, but they're going to show up as a certificate error, and you've seen certificate errors before. I'm sure different things happen. It could be that you're at the wrong place. It could be something as simple as like happened in February, that the certificate expired, nobody noticed. Different things can happen to cause those errors, but if you get a certificate error, the reason they show up is because there's something wrong with it. You need to take a look at that thing. The certificate authority, signed certificates for any network that has a WAN, like use a CA sign, and they should be CA signed. We've got to buy them, obviously, but they're going to give us things that are more reliable, more useful, more trusted, obviously, than what goes on. The certificate authority signs and revokes certificates. We've looked at the certificate and seen that it is signed, and the certificate authorities, the ones that are trusted, that get put into the browsers, and occasionally the list is going to get updated because they come and they go. There was a certificate authority, and I think it's probably 2 years ago now, that got compromised. Certificate authority gets compromised. All the certificates that they issued are now invalid. Whoever compromised them, I think it was the Iranians, they were, anyway, they were issuing a bunch of certificates to the Iranians. Must show themselves trustworthy. The certificate practice statement, root certificates are out of banned distribution. The root certificates, the certificates for the root authorities, usually, typically, I think what's supposed to happen with these things is they will create their certificates, self-sign their certificates, sign the distribution authority certificates, and then take the certification, the certificate server offline, so that it doesn't get. I want to try something here. Look at a couple of the certificates here in the hopefully in the add remove snap in. I'll bring this over. Actually, I won't. I'm going to use the certificates here, and then when I do certificates, I can get my user certificates, the service account, or the computer account. And I'm going to add me and the computer to this thing, the local computer. And when I do this, we might have separate certificates. These are the current user, these are me. I actually have a couple of personal certificates here. The certification, Cedarburg, and then you see it's self-signed. It is not going to be a valid certificate. The details, let's see, the subject, subject key identifier, digital server, it's used for server authentication. So got an X here that says it's no good. This CA certificate is not trusted. Certificate authority certificate is not trusted when we do these things. This one was one that is expired. It was actually issued from a valid location when we do those things. And the enterprise trust, the intermediate certification authorities are lots of times, these are the entities that are going to be issuing the certificates to us, so that we don't compromise. They're going to be signed by a certification authority to do these things. And this one, it's the same company, but we have the high assurance here is going to be the root certificate. It's going to be the self-signed certificate that's trusted, and then it's going to sign the issuing authority's certificate in order to be able to go from one to the other. I don't have any smart cards or anything like that, but we might have the certificate revocation list. When we do this, certificates, the revocation list here, these are certificates that have been revoked, and this was 2001. Some of these are pretty old CRL certificate revocation list, but certificates that have been revoked for whatever reason are no longer valid, no longer usable in the systems themselves. Certificate generation, we can have multi-purpose, and we've looked at some of these things, the multi-domain, the wildcard. The extended validation is one of those, and I don't know if it still works or not, that you get a different color when you go to a website. And I don't know that Edge does that. It used to be that I could get it on one of the banking sites, but not on the other one. But I think now they don't change, or maybe it does in maybe it only does it in Chrome. But anyhow, the extended validation that the trusted authority went to more research or a deeper look at the applicant to be sure that they're who they claim to be. Whereas just the standard ones, not as much identification is required for those. When we go from one to the other, and they used to, and it looks like they're not, they used to be different color. The extended validations would wind up being green to show you that they had extended validation, but right now they're not. I had two banking accounts, Navy, NFCU, and Bank of America. One did and one didn't for those things. So limited purpose, multi-domain. Wildcard would be like star.leaderquest.net or .com, so that all of the LeaderQuest websites could use that particular certificate, and then the extended validation, better research for these things. The hierarchies, and I'm sure you did this in a Security Plus, single certificate authority or a group of certificate authorities can work together to issue the digital certificates. The standalone would be me. Each certificate authority works in a parent-child relationship with the CAs above and below it. The parent here and the child. The parent's going to be the root authority, and these will probably be the distribution authorities, the ones that actually issue the certificates. The parent, the CA, the root CA, will sign the distribution certificate so that they can then sign our certificates to give a chain of custody, so to speak, a chain of authority for these things. Ensures that the CA distribute the workload and provide certificates more efficiently, as well as to, if we take it offline as it should be, to protect the root certificate for these things. If it's compromised, only its children are compromised. Its children are compromised, or as well as only its children. And that can be a significant number. The certificate authority that did get compromised is no longer in business. The chain of trust got to be signed by another CA, which is signed by another CA above it on down the line. The entity must trust all the links in the chain. And those are the what I was trying to show by looking at those certificates. Who signed them? What is the chain of trust from one to the other? The topmost CA in the hierarchy is the most trusted authority. That's the one that has the self-signed certificate, and we've looked at a couple of those. They sign themselves. Why are they trusted? Because they get put into our certificate store on our machines as the trusted certificate authorities. The operating systems, iOSs, update these things, and occasionally you'll see a Windows update that is the new certificate store that goes along with these things. Self-signs its first certificate in the chain. It must be secure. If it's compromised, all of the other certificates are invalid, and that is in fact what happened when that certificate authority got compromised. Any CA that is below the root, the subordinate certificate authorities down here, the subordinates manage the certificates. The root CA signs them, and then they can issue the certificates. Renew, suspend, and revoke. The difference between suspend and revoke is it can never be used again. If we think that maybe we may have a problem with our certificate, we can have it suspended where it is not valid for a certain amount of time. If it's suspended, then it can be unsuspended, and we can come back and use it again with it. So with that takes care of those things, and now we really are going to get into some of the things that we're going to use with Cisco, the Cisco specific items. And I think that what we want to do in this next segment is, in fact, layer 2 security. We're getting into the Cisco kind of specific areas, or at least switch layer 2 switch specific areas. What I want to do, you might guess, is to do a little demo before we do the lecture. Maybe the lecture part, the words and the pictures will make a little more sense, hopefully, when we do that. Let's say, I'm going to move this down here, that you, and you will be one day, the network administrator, let's say in a technical college. And you have students who come into classrooms. The classrooms are set up with your machines that you know have antivirus software on them, that you know have anti-malware, the firewalls are configured, that you know that they're up to date, all the Windows updates are installed on them, and you know you're in pretty good shape on these devices. You have set up a wireless for the students, but some of them don't like the wireless, too slow, to this, to that. So let's say that a student comes in, let me see what port we're on here, Fast Ethernet 03, comes in to the classroom, 20 machines, 30 machines, 25 machines in the classroom, and you can get to the wires, unplugs the wire from your machine, and then plugs his laptop into that port. That was Fast Ethernet 03. And he's up and running. We now have a device on our network that we don't have a clue about. We don't know if it's got a worm on it. We don't know if it's got a Trojan. We don't know if it's got viruses. We don't know if it's protected in any way. But now, this guy's on our network. We want to be able to do this. And oh, by the way, people that have been in these classes before said, it's not just students that do that. The bosses do those things also. I'm going to plug us back in here. The bosses do that also. There are methods, and this is one of the first methods, I think a pretty good method, in order to keep things off. And oh, by the way, when we did this, faculty get trapped in this too. Everybody gets trapped in this because they plug in devices that shouldn't be on the network. How can we prevent that? We can use this thing called port security. And it is a port by port basis. So when I go into config T, we have to configure it on the port. So we'll do interface, range, Fast Ethernet 01, and let's just do all of the Fast Ethernets to 24. The way I turn it on is, and I'm going to hopefully try to point out some things here, switch port security. It says I can't do that because it's a dynamic port. You can't configure it on a dynamic port. Dynamic ports are the defaults. The dynamic is dynamic auto that says if you ask me to become a trunk port, I will become a trunk port. But if you plug me into another auto, I'll stay an access port. We can't do that. We can't have it being a dynamic port. So the first thing we have to do is to make them access ports with switch port mode access. Then I can turn on switch port security. It's on. If I do show port security, do show, that won't work. Will it do show port security? Let's see. Show port security. It's on. It has some default configurations, and what I want to do is go through each of the things that we can do. Port security, maximum secure addresses, here it says 1, account, we don't have any. Security violations, and then the security action. The security action is going to happen if we have a violation. So let's go back to these things and go through what we can configure on this one at a time, and we'll go to the interface, range, Fast Ethernet 01 to 24, 24. And now we'll do switch port, and as we've turned it on, switch port, port security, we can configure aging here, port aging commands, and this is how long the MAC addresses, and that's what we're going to be controlling on this, will happen. We have the MAC addresses, how we're going to get the MAC addresses. By default, they're going to be dynamic addresses. They're going to go in the MAC address table. The maximum, how many addresses can we have on each of the ports? And then the violation is if we violate some of this, if we get out of the parameters, what's going to happen? So the first thing, let's go in and look at the MAC address. And there are two ways that go here. The default is the dynamics, and I guess, well, we don't have any MAC addresses on there yet, but the dynamic is just using the dynamic MAC configuration. We find these things. The HHH there, 48-bit MAC address, we type them in. You can type in 600 or 700 MAC addresses on your switches if you want to do this, or we can use this thing called Sticky. Sticky is kind of cool. At least I think it's kind of cool. What it does is the first MAC address that comes in, we can do sticky and we can add these things. The first MAC address that comes in is going to be stuck to that port. So we'll use sticky for those, and then we'll make these things happen here in a minute. Switch port, port security, and then we have the MAC address, the maximum. How many devices do we want to be able to connect to that port? One of the bullets, I think, when we were doing voice VoIP, putting phones on, where we have the phone and the computer on a port, when we had the voice VLAN, said, when we get to port security, you may have to make accommodations for that. The default maximum is 1. I'm gonna put a maximum of 1 on this right now because I want to show a couple of things. But if we had a phone on this, we might need to use more than one MAC address. And keep in mind that, and we have to see what happens, the phone might actually get detected on both the voice VLAN and the data VLAN. But the default here, the maximum, is going to be 1 for this thing. The last thing that I can do is the violation. What happens if I exceed the parameters that I have set out here? We have these things called protect, restrict, and shutdown. Protect stops forwarding packets. Stops forwarding frames. I shouldn't say packets here. Stops forwarding frames since we're on a switch. It just doesn't forward the information. So don't get any visual cue. We have to go and do the show port security in order to see what happened there. Restrict does the same thing as protect, except it can be configured to send us an SNMP trap message or a syslog message that we have a problem with these things. So shutdown puts the port, it effectively shuts it down. It's not truly shutdown mode, it's air disable mode. Air disable mode is a little different. So I want to do shutdown, and that was the default for these things. So if I go in this thing and I show run, I don't have anything except I say switch port mode access, switch port port security. And this is MAC address sticky, but there's nothing there. So what we can do, and I'm going to go into this thing and let's see if we can ping, and I won't make you go through ping, 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 192.168.1.255, and we're getting some replies back from some of these things, and not all of them. We'll make this one do something nasty here in a minute. What we wind up with here, I hope, is a listing of, or a bunch of MAC addresses. Let's do a show run here. And the MAC addresses are now stuck to the interface, this Fast Ethernet 01. I have a Mac sticky. The MAC address is in the configuration file, so that if I would copy this running configuration file to the startup configuration file, power failure, trip over the core, all of the things that you've heard me say, it can survive a reload. And that can survive a reload, that's kind of some keywords that I've seen on tests before. So we have this thing, and the first address that comes in to this is going to happen here. So on this port, let's look at our MAC address table. Show MAC address table, and we didn't get all of the ones on this one. We only got a reply from one of them, and we got 52 and 53. So what I want to do, let's try to ping, and just to go across this thing, 192.168.1. What was the other one? 52? Or did I get them backwards? Maybe. 53. We're still going here. But this one got shut down now. We're still going back and forth because we're in the hub. And remember, the address gets flooded out all the ports except the port it came in on. So we've now tried to put two MAC addresses on this one port. That won't work because we configured all of our ports to have a single MAC address. I can go in and fix that by just going into it, and I was looking at it, Fast Ethernet. Well, let's show port security. Here, this one now says that we have a violation. The action over here, shutdown, is not the status of the port. This is what happens when we have a security violation. And sure enough, we have one here that says the maximum secure port security, the maximum secure and secure are going to be the port security configured addresses. The maximum numbers that we can have on this port is 1. And this one, we obviously tried to put 2 on it, so we have a shutdown. So it's not something that somebody came in and plugged in the wrong MAC address or tried to put 2 of them on. One of the bosses tried to put his wireless access point on so that he could have his phone and tablet and laptop as well as his desktop all plugged in. We're not going to allow that because we've said that, hey, you can have your desktop that we provided you and that's it. So when that happened, we got to the violation. So these things did get violated, got shut down because that was the mode. We can fix that by going into here and changing that particular port. So we'll go into config T and interface Fast Ethernet 04, and we'll do switch port security, and then we'll do a maximum. Now let's just make it 3 just to have plenty on it. Maximum of 3. Now if I try to do a no shut, doesn't work. Change state to down. And if I go back here and no shut and it's still down. That is the air disable mode. And let's see if I can see that. Show interface Fast Ethernet 04, and I always forget which one of these is. Yeah, show interface Fast Ethernet 04. It says air disabled. It is down. The line protocol is down. It's in air disable mode. One of the differences, if we had shut down, we would just have to give the no shutdown command on it. Interface Fast Ethernet 04. But in this case, I have to bounce the interface. Do a shut, and then a no shut. And then a no shutdown. So now I should be back up. And I am. If I go in here and look at my show port security, show port security with a hyphen, and these are the things that'll get you the hyphens and the spaces. That we're now okay, but now it says we can have 3 secure MAC addresses on this. We don't have them all on it yet, but we could go into this guy and ping the 1.53 again, and that should put that MAC address. Yeah, we now have 2 MAC addresses on this one. 3 is the maximum. We're okay. We don't have any problem. If we do have a problem, it's going to be shut down. So now when my student comes in and unplugs the corporate machine and plugs in his laptop, he's not going anywhere. It's in air disable mode. I like air disable mode because it doesn't confuse me as much. If I use protect or restrict, and by the way, I kind of figured out eventually, I said, oh, one of them stops it and the other one stops and sends you a message. I finally figured out that these things actually go in alphabetic order. P, we don't have a Q, R, S, protect, restrict, and shut down to do that. And you know how long it took me to figure that out when I would always try to remember. But protect just simply starts dropping the data frames. Restrict drops them, sends us an NMP trap or a syslog, can tell us something has happened bad. Shut down puts the port in air disable mode. We'll get a visual cue for it because the LED will turn from green to amber when we go into shutdown mode. So physical cue, and that's the reason I like it, is because I get the physical cue. I can now put my guy back on here, and again, that's not going to bring it back up. I've got to go in and do the physical configuration. Now there is, we can show port security here, and again, now we're going to have this one has got security violation count on this one, and then it's shut down. So I have to go into the interface fastnet 03 and do a shut and a no shut in order to bring that interface back up. There is a configuration that is an auto recovery mechanism that you can configure. Can't do it on Packet Tracer, but that you can configure so that instead of having to go in and doing the shut, the no shut, auto recovery, we can configure certain instances, certain things that we can recover from, and the too many would be one of them. So that once we fix the problem, and it goes and does kind of a polling ever so often, whatever the time interval is that we configure, that checks to see if it's been fixed. If it's been fixed, it's going to come back up. If I try to recover, as you saw, hopefully, well, I didn't, but if you try to recover before you fix the error, then it's just going to error again. So we can do these things. One of the steps, or maybe step 1 on the switches on security, port security. Port security, the first one that we're going to look at in these things. Access control list, the layer 3 security that we have. And you know, if you do this, configure this, you'll find that a lot of people are going to mess this up. It wasn't just the students that did this. I had faculty would do it too. And sometimes they'll say, hey, the internet's down. Sometimes they'll just, I know I did something wrong, so I'm just not going to say anything. I can't get there. Pretend that it didn't happen. If you've got the switch that's visible, you can see on the LEDs what's going on with it, with these things. That's just one of the protocols I think is a really cool capability to keep unwanted MAC addresses off of your network. Yes, I know you can spoof MAC addresses. You can also create your own issues. You know, been there, done that, screwed up a lot of stuff. But I used to use in the room one of the rooms that had this configured on it use a virtual computer. Well, first time around, I said, yep, I know I got to do this. I got to have more than one MAC address. So I allowed for that. And come back to the same course as like, a quarter later, 3 months later, 4 months later, and turn the virtual machine on. Well, it generated its own brand new MAC address. So it shut the system down, shut the port down. You got to go back and do it. And then allow or take the old MAC address off, and you can remove those with the no command. What is it? MAC address sticky, and then whatever it is. And again, copy and paste for those things. And I guess we could look at the copy and paste of that in order to make one of those go away, just so that, yes, we can copy and paste these things. So if I go in here, and the easiest thing would be to do show run, and then I have on Fast Ethernet 03, I have this one. I can copy, and I am already on it, and I should be able to do in this interface no, and just do a paste and take that MAC address off. Do show run. And now on Fast Ethernet 03, I don't have a sticky MAC address anymore. So if you need to remove them, and you may, particularly if you move computers around. Actually, this thing is supposed to be smart enough, and I don't think that Packet Tracer is, that if I moved from one to the other, it's supposed to be smart enough to move that. The actual switches are, and it's still an error. It's called a MAC move error, but it will actually move these things, but still give you an error message for them. So layer 2, back to what I used to think anyway is just some place that we plug things in. The switch actually has, we've seen now several configurations that can happen with it. I think this is one of the more significant ones, that we can create some security here at layer 2. If I can create security at layer 2, then I don't have to worry about it at layer 3 or any of the other layers, because I've now prevented that virus from getting on the network by simply not allowing those devices to be plugged into the network when we do those things. And the one where, plug the right one back in, it's still going to be down. It doesn't care. It's got to wait till we go in and fix the problem. Or if we have the auto recovery configured until it does its auto recovery thing. Layer 2, devices that use MAC addresses to forward data. We can use in here port security, secure MAC addresses, DHCP snooping, one that we will do a little bit. It's another cool one. It's going to help us prevent the man-in-the-middle attack from the rogue DHCP server, and then ARP inspection, dynamic ARP inspection, where we will then be able to mitigate, and I want to say prevent, and I'll say mitigate, which means that we think we got it done, but somebody may slip one in, the ARP spoofing capability. So port security allows the restriction of the number of devices that can be connected to switch interfaces. It allows the number that we saw, but it also allows only explicit MAC addresses based on how we configure it. Uses the source MAC address of the Ethernet frame to identify the devices, just like we did with the MAC address table. They go into the stickies go into the MAC address table, but they also, as you saw, go into the running configuration file. If we want them to be in the startup configuration file, we still have to do the write or the copy run start. The books, a number of the books, I won't say all of them, give the implication that they say, well, it'll survive a restart. It'll survive a restart if we've copied it into the startup config file, but it won't until we do that. has no restrictions on whether the frame came from the local device or was forwarded through other switches. What that means is if we have a switch to a switch sort of arrangement, we can, on the ports that connect the switches together, can have port security. I think, opinion, that kind of painful to try to do. Plus the fact if we have multiple switches, why would we need it on the ports that connect these things together? Because we'd already have controlled our port security. So if we have multiple switches here with this thing, different size switches, with this thing, and they're connected together, we'll not do a loop. We'll connect them like this. Then we probably don't need port security here because we have port security on all of these ports. So we have assured ourselves that these are ours. And we've assured ourselves that these are ours over here and that these are ours down here. So do we need to check these? We can, but, and you can do it on a trunk port. I say that, I'd have to try that out because there are some rules that get kind of weird in here. What it can't be is a dynamic port to do these. So it can't be auto or desirable. And we can make trunk ports not auto and desirable if we want to. So, but again, if we already know that all of these have been verified, validated up here, why worry about it at these points? That's just up to you when you start doing the configurations, how you want to do them, what you want to do with those things. And I think it's just going to cause, I think it's just going to cause you more issues with this. No restrictions on whether the frame came from the local source or was forwarded through the other switches when we do these things. This shows a hub, and what can happen here, the hub, and you saw we had the hub, all of the ports off of the hub or all the MAC addresses off the hub are going to be on a single port. And yes, we can configure that. We can configure the ports individually. It's why I tried to do it that way so that we can have the flexibility that we need. If we have a machine that's running a virtual machine or a couple of virtual machines or a dozen virtual machines, we can configure that port to accept those virtual machines and put their MAC addresses in there so that we still have the restrictions that if somebody puts something new on there, it's not going to work. It's going to do whatever we've configured it to do in the violation mode, either to drop the packets with a protect, shut down, or with the restrict to drop and send us a message. This one is the things that we did, switch port security maximum 2, and instead of using the sticky, they've opted to type in the MAC addresses. That's up to you. Depends on what you want to do with these things. To me, sticky, if you do it, what we did to ensure that we had them, we didn't have classes in the afternoons. So after everybody left, when the first time around, we configured our switches, and then we turned all the machines on so that they would send their MAC address into the port, so that we use the source MAC address to then populate the MAC address table, obviously, but also to populate the running configuration file with the sticky addresses. Determines which frames to filter. Port security, using the 3 basic methods, limit the specific MAC addresses that can be allowed and receive, discards frame from the other MAC addresses. This would be in, actually, that is a limit the specific that can be allowed to send the MAC addresses, discards frames from other MAC addresses. If we get into violation mode, the port's in violation mode. So this is, and I didn't write this particular bullet in this one, but discards frame to and from other MAC addresses. If it's in violation mode, it's in violation mode. It doesn't matter if it's the correct MAC address or the incorrect MAC address. Once we get into violation mode, it's going to stay there until we either do an auto recovery or we do the shot no shot when we do the manual recovery of these things. So discards to and from, discards frames. To and from, okay, I read that wrong the first time. Just to or from other MAC addresses, discards all the frames, and I guess that I got panicky on that one. Discards frames to and from MAC addresses that are learned after the maximum limit is reached, because they're not going to be recorded with this thing. Combination of two methods. The switch port security maximum interface command allows configuration of the maximum number of secure port addresses allowed on that. The default number is 1. If we didn't configure anything, it would be 1. And I guess that, let me go back to, and this is going to be the switch that we did. And we do the show, you notice that the maximum doesn't show up any place except down here, because the maximum 1 is the default. The defaults don't show up in the Cisco configuration files, but when we do something out of the ordinary that is non-standard, it's going to show in the config file. Sticky is not the default. The default is the dynamic addresses, where we just detect them as they come in, just like we did regularly before we did port security. Normally support 3 types of secure addresses. We have the manually configured, where we type them in, stored in the MAC address table, and added to the running configuration file. The static secures are going to be that way. We type them in, and they are then going to be stored in the address table and added to the running configuration file. Remain until they are manually removed. The dynamic secure, these are the kind of the regular ones that we use, are dynamically learned. They're only going to be in the MAC address table. Dropped when the age limit is reached, but the port security disables aging on these things. So yes, if we get there, but aging is disabled when we configure port security, and I think that one of the later slides says that. They're not persistent, lost when the device restarts, and this is going to be the case. Now the stickies are going to be also, as will the statics. The static here is manually configured, stored in the address table, added to the running configuration file. Remember, the running configuration file is in RAM. It is volatile. Anything happens to it, it's gone. So those are going to be there. They're going to have to be saved into the startup configuration file. The dynamic addresses can't be saved there. They're going to, if we restart, are going to be there. They can be converted to sticky MAC addresses with the switch port security MAC address sticky command, and to me, that's the one that I prefer, as you can probably tell, because they go into the configuration file. I can see them, I can change them. They can be persistent, and particularly if you have reloads, any kind of a reload would then open itself up to a compromise of the MAC addresses if we didn't do it that way. The types of dynamically learned, manually configured, the statics, the sticky secure, the dynamically learned, or manually configured, stored in the address table, added to the running configuration file, and in the running configuration file, they would be lost on a reload. We can put them in the startup with a copy run start, stored in NVRAM. But not displayed in the running configuration file. If they're stored in NVRAM, they're also going to be stored in the running config file. When it's disabled, when sticky is disabled, they're converted to secure dynamic. If we change the type that we use, the type of MAC addresses that we use, the dynamic secure, again, just go into the MAC address table when we do these things. So a summary of what we have for these things: the static are going to be in the running config, can be saved, and they'll be in the MAC address table. Dynamic is only going to be in the MAC address table, just like the ones that we had before. They're dynamic, and the only real difference is that the timing out of them, because again they have the timer is going to be disabled for when we go into port security. Sticky is in the running config file as well as in the MAC address table. And I think this, if you look at these are kind of sort of at least what we did. Show the running config, building the configuration, switch port mode access. We had to have switch port mode access. We can't do them in the dynamic mode for the interface. Switch port security maximum, whatever we want to have. This one happens to be 5. Sticky will automatically find those. That does not mean that we can't put our own addresses in here. We can manually configure them and then get the rest of them from Sticky if we want to do that. Guidelines for configuring port security can only be configured on static access ports or static trunk ports. That's, you saw when I first started that it was a dynamic port, said nope, you can't do that. Voice VLAN is supported only on the access ports. Dynamic port security is automatically enabled on the voice VLAN. And then an IP phone will require up to 2 MAC addresses, one for the phone and one for the PC. There are instances where the phone gets detected in both VLANs. And in that case, you'd have to have 2 for the phone and 1 for the computer. Probably not going to happen, but if it starts going wacky on you, that's one of the things to consider, that the phone reported itself twice. Cannot use it on a destination port for span. Span's a switch port analyzer, a port mirroring situation, something that I don't think, no, we haven't done yet. It's a pretty simple one. That's where we can monitor one port on another port, because remember, in switches we only see the traffics to us and the traffic that is broadcast. If we want to monitor other ports, we have to configure the switch port analyzer in order to do that. Cannot belong to an ether channel port group. A secure port cannot belong to an ether channel support group to do this thing. So ether channel, no. When changing the maximum secure address of the interface, if the new value is greater than the existing value, it's okay. If it's lower than the existing value and we have that number of devices on that interface, it'll be rejected. We can lower it as long as we hadn't topped out. And what this is intended to say is lower than the existing value and the number of devices. If I put 5 on it and I decide I only want to have 2, then I can change the maximum value, as long as I don't have 3 devices on it. I can't make the MAC, in other words, what I can't do is configure it so that it's going to be in a violation state. Static secure secure MAC addresses cannot be configured on the voice VLAN, and the Cisco switches do not support port security aging on sticky secure MAC addresses. The aging MAC addresses learned dynamically will be dropped when their age limit is reached. The age limit can be configured on each interface, ranging from 0 to 1440 minutes, and with 0, aging is disabled on the port. Aging is disabled with a 0. Not on the port, but on the MAC address table. Which devices age? We got inactivity, and this is the one that it gets reset. Sets the length of time after the last packet was received from an address. So we get it, it starts the countdown timer. We use it again, so we reset it. countdown timer reset it. The other one is absolute length of time after the address was learned by the device, and this is the default aging process for these things. Maximum addresses for these, the default value is 1, can be modified. We did that after setting the number of maximums on the secure MAC address. Can be secure addresses can be added with a switch port security MAC address by statically configuring them. If we want to type in the MAC addresses, use the port security MAC address VLAN configuration command for trunk ports to configure secure MAC addresses for a range of VLANs, and then allowing the port to use the MAC address to connect to dynamically configured secure MAC addresses. Configure the some of the addresses to be static and the rest to be dynamically, and we can do that, but we're obviously going to have more than one when we do that. We might have some static addresses and then configure the others to be automatically detected in those. The event triggers the maximum number, which we've seen the maximum is reached, then whatever the security violation is going to, whatever security violation we have configured is going to be triggered. When the MAC address configured or learned on one secure port attempts to access a different secure port in the same VLAN, we move the cable from one port to the other in the same VLAN. This is called a MAC move violation, but it is a violation. The violation modes we've looked at: protect, this is not recommended for trunk ports, disables, and it I guess kind of confuses me because I'm simple. I have one of these simple military minds, but feeble military minds, I guess is what they talk about. I don't get a visual indication. I have to go look at it, and then it's like, okay, nothing's happening. Why isn't anything happening? Oh yeah, port security is there. If I have shutdown, same kind of things are going to happen, but I can look at the switch and say, hey, something happened because that port is amber. What happened to it? And I can go look and see what goes on. It gives me a visual tipper with the shutdown. But it disables learning from any VLAN that reaches when it reaches the maximum, even if the physical port has not dropped the frames from the offending devices and there's no notification with the protect. And again, alphabetic order: PRS, protect, restrict, and then shut down. Restrict, same as mode, except as noted below, it's going to send or can send, if it's configured, an SNMP trap or a syslog message. And it increments the violation counter, whereas the protect doesn't. So it's one, protect is one that, it can not give you the indicators that you might expect to see with these things. And shutdown is the default, puts it in air disable mode, and we saw that with the show interface command, that it was in air disable mode, not in shutdown mode. The steps are the ones that we just used: the switch port mode access or switch port mode trunk. We saw that when I tried to do it before I gave the switch port mode access, made them access ports. It said, no, you can't do that. Switch port security interface, we can do one at a time, or we can do a range of interfaces. I did the range of interfaces. Maximum, the optionals are the maximums. Here, the port security violation, the configurations that we did. Port security MAC address, although I didn't use the manual in order to do that, in order to type in the MAC addresses. We use the sticky to do that, the kind of the lazy man's way to do these things, to go from one to the other. Air disable mode is effectively shut down, but it is a little bit different because we can't just do a shutdown. Shutdown is the name of the violation. It puts the port in air disable. Effectively shut down, can't send traffic. The LED of the port will be orange or off depending on what the switch does, and that most of them are orange, or amber is the color that I think that's the name that Cisco uses for those. Output of the show interface commands shows the port status is error disabled, and we saw that when we looked at the show interface. Fast Ethernet 03, whichever one we were looking at. Serves two main purposes. It alerts us to a problem, and that's me, and I've been saying that I have a visual cue. Something happened. Something's wrong with this thing. Prevents the erring port from causing other ports to fail. And the bad port can monopolize the buffers or have issues with it. The error disable recovery mode is an auto recovery mode. Error disable full, this is the status it's in. If it's re-enabled prior to fixing the problem, it's going to error again. What we can do is configure the error disable recovery mode, and this is to show error disable recovery. These are the things that can be recovered from when we do these things. So down here we got the MAC limit disable. We can turn it on so that what would happen after a while is that the 300 seconds to 5 minutes, if we fixed that problem, it would automatically do the recovery for us, do the shut and the no shut. We now put the correct MAC address on it. It will automatically recover. But again, we have to configure the time interval. The default time interval is 300 seconds, disabled by default when we do these things. If it is disabled, the manual re-enabling must be done with the bouncing of the interface, the shut and the no shut when we do that. These are the default port security configurations. And the reason I put it in here, port security disabled. It's not on. We had to turn it on with the switch port security command. The maximum number of secure MAC addresses was 1. We saw that, although I set it for 1, but when we looked at the configuration file, it didn't have anything in there. So the defaults don't show up. It's going to be 1. The violation mode is shut down. Aging is disabled by default. The aging type is absolute by default. Static aging is disabled, and sticky aging is disabled. So static aging is disabled. We say static MAC addresses don't age out. You can set static aging. You can turn it on so that the static MAC addresses will age out. You can do your own on that one. I don't know why you would want to do that, but you can configure it should you want to do that thing. We can configure aging on the sticky if we want to. We have to turn it on. It's a capability. Is it something that we want to do? Yeah, probably not, but it is something that can be done. So we have here 35 minutes worth of labs, and let me see what's next. When we do that, I guess that let me do is only just a few slides for ARP snooping, and then we can actually, let's do a break and come back at 5 past, and then we'll do DHCP snooping, and then we'll work on labs and then go to lunch. Questions or comments? The next kind of short topic, but very powerful one, is DHCP snooping and dynamic ARP inspection. Some of the man-in-the-middle attacks that we have, and again, I want to do a demo of how this works. This is DHCP snooping. Dynamic ARP inspection I can't do on Packet Tracer, but in our world I have a DHCP server up here, so we get addresses from it, and as we know, and I think that they already have addresses, and they do have on a 192.168.1 network, we have addresses. We know that if somebody is able to plug a rogue DHCP server in here, they can give at least a portion of our clients false IP addresses. And they could then send that information through themselves, and they could then do all the things that we talked about this morning that a man-in-the-middle attack would do. we can configure this thing called DHCP snooping when we do this, unless it's IP DHCP snooping, and we just turn it on the entire switch. The problem is what it does. It's not a problem, but it just the configuration that you have to know about. If I go in here now and try an IP config renew, I should get a, and I don't. Oh, I know why, because I have to specify the VLAN. IP DHCP snooping VLAN 1. Maybe that'll work. It's supposed to show run. Let's see if I got it here. If I got it here, yeah, IP DHCP snooping VLAN 1. It is a per VLAN sort of arrangement. Let's see if I've broken it now, which I haven't. Which tells me that I already have configured down here, and I didn't look, a trust. So if I take this off, if I unconfigure what is configured that it shouldn't be, interface config T, interface gig 0/1, gig 0/1, no IP DHCP snooping trust, and then do show run. Be sure I've got this off. What was supposed to happen, and now I got all the other configuration off, got a little ahead of myself, and I know what happened is I did a reload, and that was saved there. So now my DHCP is going to fail because I've now made all of the ports on this switch untrusted. Go back and redo what I undid on the port that goes to the DHCP server. I can now configure it, interface gig 0/1 with the IP DHCP snooping trust, and I should now on my trusted DHCP server be able to get IP addresses for this thing. So I can now get my IP addresses again. Sometimes, and we'll see, and I'm making excuses before we get there, sometimes show IP DHCP snooping binding. Sometimes it's slow, but this time it worked. What DHCP snooping also does is to create this binding database where we have the MAC address, the IP address, the lease time, DHCP snooping the VLAN it's on, and the interface that it's on. So we now have a database other than the MAC address table, which has the MAC address associated with a port number. Now we have the MAC address associated with an IP address. So that somebody tries to spoof the IP address, we have an issue. The other thing that uses this is this process called dynamic ARP inspection, where when a MAC address or an IP address answers with a MAC address, it checks the snooping database, and if it's wrong, say, hey, we got a problem here, it's wrong. That is the way that we can prevent the ARP man in the middle with the ARP spoofing attacks for these things. So the slides here. DHCP snooping, a security feature that detects rogue DHCP servers and filters the DHCP traffic originating from untrusted devices. Our workstations are untrusted devices. I did what happens, and just to see, I did a a scan of one of these things to be sure to see what's going on with it. And when we look at it, let me see if I can open it up here. What happens is that we only see part of what goes on with this. Actually, what goes on with this is on the untrusted, it only allows us to see or to use or to get the discover message. So we use DHCP here, discover offer, but when I get down to where I actually had this configured, we get a discover going down here. We don't actually get the offer coming back from the untrusted port. So what it does is protects the DORA process, the DHCP process for these things. Acts like a firewall between the untrusted hosts and the DHCP servers, identifies and filters the DHCP messages, and we can implement rate limits, how many packets can go, or frames can go back and forth on the switches itself. Builds and manages the DHCP binding base, which we saw associates an IP address with a MAC address. Validates all of the subsequent requests. Help to determine the trusted and untrusted sources. Trusted, the devices under our administrative control, and the untrusted is going to be everybody else. When we configure this, all the ports except the ones that we go in and explicitly assign as trusted are going to be untrusted ports. When enabled, all the ports are untrusted by default. We can configure the desired ports as trusted, the ones that have our DHCP server on them, and then enabled on a per VLAN basis when we do these things. Protects against bogus gateway assignments from the rogue DHCP servers, so that that we don't get somebody going from one to the other. The binding database, which we looked at, dynamically built, maintained by the snooping feature, contains an entry for each trusted port that gets a DHCP address. The MAC address, the leased IP address, the lease time, the VLAN number, and the interface, the things that we saw in the show on the switch itself. Updated when the switch receives certain messages from the trusted port, the DHCP acknowledgement from the trusted ports. Actually, it doesn't allow the offer to come back, as you saw in the Wireshark scan. Enables the storage and retention of the binding preserved across the reload. So there is an agent that keeps those bindings so that the binding table will stay if the device is reloaded. The bindings are for the untrusted ports, the MAC address, the IP address, the VLAN it's on, the interface, the things that we would expect to see. The binding agent for these things allows us to retain the bindings across the reloads. In the absence of the agents, they're going to be reestablished by DHCP feature after the reload. Stores the bindings within a file at the configured location. When the switch is reloaded, it'll read the file and rebuild the database for the bindings that we had before the reload. Writes the file as the database changes to keep the file current, and then each entry in the file is tagged with a checksum in order to be sure that it's not been compromised. If we have and each of the entries in the binding database are for DHCP addresses. If we have static addresses, we can put manual entries in there so that we don't have the ARP spoofing issue going on again. Option 82, the DHCP client generates a DHCP request and broadcast the request to the network. This is a situation where we're going to send information from one switch to the other. We're going off of our switch to another one. Switch receives the DHCP request. It adds the option 82 information. This is just other information about the DHCP client on the request itself. If we enabled port-based authentication 802.1x, the switch will add the 802.1x authenticated user identity information, radius, attributes, or a sub-option to the packet, so that additional information, that what it's really doing is allowing the answer to get back to us when we get back from the DHCP server. If we configure the IP address of the relay agent, the switch will add the IP address of the DHCP packet, and then the switch forwards the DHCP request that includes the option 82 to the DHCP server. Must be configured to handle option 82 information. If it's not, it's going to drop the packet and we won't get our DHCP address for it. Option 82, more option 82. The DHCP server receives the packet. If it supports option 82, it assigns the IP address, adds the reverse information to it, be able to implement policies. Server will then echo the option 82 field in the DHCP reply, and then unicast the reply back to the forwarding switch to do these things. The switch then is going to remove the option 82 information and send the DHCP offer the answers back from or frames back from the DHCP server to the DHCP client. Dynamic ARP inspection, and this is the one that's going to defend against ARP poisoning. A security feature validates the ARP packets that contain a valid MAC to IP addressing. Dynamic ARP inspection depends upon DHCP snooping to be running in order for it to work. Defends against ARP poisoning, which can be a man-in-the-middle attack, which is one of the methods for man-in-the-middle attack. Intercepts all the ARP traffic and compares it to the snooping database. If the bindings are valid, then the packet goes forward. If it's not, it's going to be dropped. So DHCP snooping and all these layer 2 capabilities allow us to prevent a number of attacks on our own network. DHCP snooping, port security, DHCP snooping, and then the dynamic ARP inspection on top of it. So that should take care of the material we covered before lunch. Work on labs until lunch, and then we'll come back at the regular time, 2 o'clock Central and 1 o'clock